now gets to kind of like mobilize the full breadth of the university to try to make us a better institution for getting ideas, technology, policy out into the world. And so in her own practice and work, she works on leading edge issues and then coordinates and facilitates these conversations amongst innovators, companies, and others. So we're thrilled to have her moderating the panel. Thanks for being here. You're wonderfully human. Let's go.
Wow, that's a tall intro. I am so glad you guys are all here, but I'm more glad that our panelists are here because I think you'll be really excited to hear about their story. I would be remiss to start an AI panel without mentioning the Pope's encyclical this week. How many of you saw it? Yeah, there's been a lot of stuff in the news. We have some breaking news of our own, but I wanted, did anybody read the 46,000 word? I will tell you there's a section in there, section 101, where the Pope does talk about the connection between AI and climate. And he framed our session for us. So I'm going to read you 3 sentences to frame this. And it starts, the gains in efficiency and the potential to improve certain services are clear. Yet rapidly and uncritically adopting them exposes us to a range of risks, including the tendency to overlook the environmental impact. Current AI systems require enormous amounts of water and energy, significantly influencing carbon dioxide emissions and place heavy demands on natural resources. For this reason, it is essential to develop more sustainable technological solutions that reduce environmental impact and help protect our common home. So I am really excited to say our panelists have already heard the moral calling and are doing this work. And we're going to do some introductions, and then I'm going to ask them some questions, and then I'm sure you'll have some questions for them as well. I owe you that.
Hi, everyone. I'm Sam Grassley. I am a Senior Director of Partnerships and Policy with Elemental Impact. We are a nonprofit investor in climate technologies, and we've been making investments in the space for over 15 years. We are very obsessed with the scale problem related to climate technologies, and we see a lot of amazing technologies and know that they exist, but that they exist and they work, but we are focused on getting them deployed. And so I work with corporate partners to really try to embed these technologies into existing purchasing and corporate offtake so that we can get to the scale that we need. So we have a program I'll talk a little bit more about focused on that, and we broke news on that today, which is exciting. And yeah, I'm excited for the convo.
Thank you, and I cannot wait for this discussion. Thank you for having me, and thank you for having me back. I am a student entrepreneur here from Yale back in the day, so I started my first company back in college, so really excited to be here and speaking to the entrepreneurs out there as well. We focus at Row Impact on forecasting the decarbonization potential of emerging tech, and we sell primarily to institutional investors and large asset managers, so all those that are deploying gobs and gobs of money, and they have to put it into various asset classes and various managers within each class and various funds and various companies. It's a difficult data problem, and it gets fuzzy really, really quickly. And so in terms of the scaling of infrastructure and trying to accelerate decarbonization, I think that's squarely in our strike zone of what technologies have the potential for impact. How can you be sure, especially when every forecast is inherently a guess? That's the world that we live in. So really excited for this conversation and to carry it on.
Hi, everyone. I'm Brandon Middaugh with Microsoft. My role at Microsoft is leading our Sustainable Market Development and Climate Innovation Fund. And what that means is going out and proactively building the external solutions that we need for sustainable business growth. In the past 6 years since we launched our Climate Innovation Fund, we've deployed a little over $800 million to a portfolio of 68 investees. And what they have in common is contributing a vision of how to build that market of the future. And our activities span carbon, water, waste, and ecosystems. I'm happy to have one of my former colleagues from the water work here. But the reason I'm so excited about this conversation is not only that it gives me an excuse to be back on campus, but also a reason to look at both sides of the ledger in terms of how are we building the infrastructure, charting that path for infrastructure, which is still unwritten, and I'll talk more about that in a moment, as well as ensuring that the applications of these new technologies are human-centric, are socially beneficial, and represent the best of humanity. So I'm really looking forward to this discussion today.
Great. So I want to start. I think there is a lot of myth and a lot of hyperbole around AI and data centers, how much energy they use, how much water. There's this question even of can you type or should you type the word please and thank you when you're writing to your agent for fear that when machines take over, they will remember you as being kind or not. And I have seen studies on what the cost of that water and carbon is just for the please and thank yous in these models. I think it'd be great to hear from you guys about what's the reality. What are the 2 or 3 binding constraints on scaling these data centers? Is it interconnections? Is it energy access? Is it permitting? Is it water?
So something that we've gone through a really in-depth exercise over the last year working with hyperscalers, trying to identify what are the things that could be accelerated the quickest in the data center context. And I think that what we see is like the speed to power issue is definitely top of mind. And so we're really focused on how can we bring in technologies that bring in new generation, new flexibility. We're looking really deeply at energy storage, for example, as a way to bring flexibility into data center environments. So those are opportunities that we really see. And the challenges are definitely there in terms of how our grid is currently built, right? We have not been building for the industrial needs that we have now with data centers, but the technologies are there. We just need to be scaling them up in the data center environment. So that's where we're focused.
Adding to that, I would say, so I joined Microsoft about 10 years ago in the cloud growth, but not yet AI growth era. And I would point to the primary constraint being all of the energy systems constraints that you listed off, Julie, and I think that they interact with one another. Some, but not most of them, are technology questions. Many more of them are market design questions, as well as behavioral or regulatory questions of how we permit new sources of generation, new transmission on the line.
This is actually not my area, so I'm going to have the layman's term here. I don't go on the deployment infrastructure side, but I will tell you this is also a major policy issue. You look at a state like Virginia, which is where I live, and we are a net importer of energy today already. That's a problem, and we're already now permitting well ahead of where that net import is even today. So I think it's important to also remember that it's a policy decision and it's a real estate question. You know, most of these really come down to where in the world is it going to be sited and what natural resources exist there and can you responsibly utilize them. So there are downsides to that, but I think one of the upsides is that pressure is economic immediately, and that kicks people into high gear to figure out a solution to it, not because they care to, but because they need to.
Okay, so I think then the next question becomes, as you've talked about this role of trying to scale these technologies, can you talk a little bit about what technology attributes are actually needed? Maybe not the specifics of the technologies, but is it reliability? Is it risk reduction? Is it cost? Is it speed to power? What are the attributes that you guys are looking for to identify technology winners or losers?
So for the data center context, I think we're really looking at things that can scale really quickly. So if a technology works on a like pilot level, but it doesn't have line of sight to supply chain or sort of greater pathway to scale in the near term, it's just not going to be bought and not prioritized. And so we're seeing that, innovation is only half of it, but that sort of scalability of the technologies is really most important. Obviously, reliability, there's not a lot of room for downtime on these, and there needs to be redundancies, so that's something that we look at too. And what we're looking at Elemental is trying to see data centers as a forcing function for broader decarbonization technology. So can it work in the data center, but can it go on to scale into hospitals and schools and other use cases? So we're trying to use that as a point to catalyze these into a new sort of industrial purchasing.
I would add another example of the same concept that Sam was mentioning, which is because data center infrastructure represents a critical load environment, if something works there, you can be relatively confident it will work in other critical load environments. One example of this is we have deployed Grid Interactive UPS, which is an uninterruptible power supply that can follow a frequency regulation signal so that it's balancing out wind generation, for instance. And there was a question, okay, we're gonna test this. What type of frequency should the signal have? Should it be 2 seconds? Should it be 15 seconds, a minute? And we said, well, if you're going to do it, you need to do 2 seconds because then you can have some confidence in the other slower response applications. And so that solution has been deployed in Ireland, in PJM, Chicago, and Virginia as well. And so I think it's an example of taking that tightest zone of sort of an operating envelope and then looking, okay, now that we've proven it in this environment, where else can it work? Hospitals are another great example of critical load.
And I'll just say from the emerging technology side, the most success that I've seen coming out of especially data centers, this is pretty broadly applicable though to kind of physical climate technologies, is really think about the deployment, the physical deployment characteristics, because there are two things there. Number one, it's not software, so you can't pivot as quickly. We all kind of know that inherently, but once you get something onto the ground and it doesn't fit, well, you're kind of dead in the water on that one. So think really critically about, is this fitting into a server rack already that meets the spec of existing data centers? Is this something that is a drop-in replacement? Is this something that's so modular that it can literally be in the shed out back, right? I mean, that depends on the component. And the startups that are thinking about deployment and physical characteristics and getting rid of any semblance of green premium thinking that kind of got us to this point, but largely speaking, unfortunately, just failed. Nobody is going to pay extra for anything. I think that is a harsh reality that is real, economically speaking anyway. And in the emerging technology space, what I'm encouraged by is there's a pretty big step change in thinking around people just getting back to basics and saying, what do we need for this to not only meet but exceed cost parity quickly, and being on that trajectory right away. And that's how you get then deployed into the next build out, which take months, years to go. So you got to get into those build outs.
So I think that raises this really interesting question about the ratepayer pledge and this idea that the hyperscalers are willing and will pay this extra cost to bring this new energy onto the grid. So can you talk maybe a little bit about this contradiction of we won't pay a green premium and the ratepayer pledge?
Because we have a fee on a carbon fee, we do pay a green premium. So the ratepayer pledge, for those who are unfamiliar, is a commitment by the major compute infrastructure developers and operators to pay our fair share of incremental energy infrastructure in particular. And you see this in a few places, but I think it's really a critical element of a broader concept that we consider a community-first AI principles. And for us, that covers energy, which is addressed in the ratepayer pledge, water, taxes, jobs, and skilling. And it's really about the overall deal that infrastructure providers need to bring to the communities in which they operate. This needs to be holistic. It needs to encompass resource footprint, but also social footprint and social impact. So we think of those 5 dimensions. And the ratepayer pledge is specific to energy, but it really reflects work that has been happening for decades to design custom tariffs that ring fence the costs of building out new generation infrastructure and or transmission, and then ensure that those are covered on a standalone basis, not by other ratepayers or rate classes, but by the net new loads that are coming to the system.
If I may really quickly, because that's a critical point. Microsoft, by the way, does an exceptional job, and some very large companies are. So let me clarify my language on the green premium because I think it's important. I'm really speaking to climate innovators bringing new emerging technology to a market. And I think that years ago, there was this belief that because it is better for the environment, people will pay and subsidize that additional cost. And I think by and large, that's simply not true. And I think that energy and purchase agreements are in a category of their own given the scale and the players who are there in the market. But the young emerging technologies that are actually surviving today are those who take a really clear look at the economics from day zero and they figure out how to just be better because they're using lower energy, fewer materials, lower supply chain risk. They're just better.
In the spirit of enthusiastically chiming in with that concept, this is where the panel gets good sparks. I would just say that I also think the concept of a green premium by definition needs to be transient in order for a solution to have a long-term economic outlook. And so while we see it as our role to be an early adopter of these solutions and to address that, I think this is the right guidance for innovators, which is designed for unit cost parity or better.
So I think that sets you up as the investor looking at these emergent technologies. Maybe you want to share your news and then how you're going to go out and look for these emergent technologies.
So just today, this is why I'm a little sleep deprived today, we announced a new deployment investment initiative in partnership with Microsoft, Amazon, Google, and Meta. And what we've been working on over the past year has been really convening these, like the biggest infrastructure players in the world to talk about what are the exact constraints, what are you looking for to buy, and importantly, what are you willing to kind of work across each other to identify solutions that we could scale across the broader industry and not have companies going individually to each company to get validation. And so we've been raising philanthropic dollars, which is a model that Elemental always does, but we've had a lot of interest because there's so much interest in solving this data center problem. And we're going to be investing in 5 to 10 pilot projects that aim at decarbonizing data centers. And so we're looking at those across energy storage, we're looking at advanced electrical systems, low carbon materials, and water positive technologies as well. And so we have, it's a really exciting moment because this is like a real big market signal that these companies are interested in buying these solutions. And we're also getting information to make them like purchasable in a way that is really exciting, kind of hasn't been done before. We've done partnerships in the past, but this has been like 10 levels deeper. And I think it's really going to be a deployment catalyst for these kinds of climate technologies. So we're really excited to be working on it. And Brandon's team at Microsoft has been such an amazing partner on this throughout the year too. We've been convening, I now know like 10 teams at Microsoft. I started just knowing the Climate Pledge folks. And so it's an exciting moment for us. And we think that this will be something that the startups really need to get into this industry.
Great. Can you? So, Brendan, I think it'd be great to hear from your perspective why Microsoft would do this and go this route and use something like Elemental instead of a not-for-profit that has this impact investing angle to it.
Yeah, so I think I love how Sam described this, and we are so excited about this as both a signal to the innovators and a more efficient way for them to trial their technologies and de-risk them for this important growing end market. It's also incredibly helpful for us as we're looking at new technology adoption. We have a team our R&D team that trials new technologies, and their bandwidth is limited. And what you start to see is that some of the most promising of these sustainable innovations, they'll be doing pilots with each one of these industry partners all in parallel. And we figured, how can we accelerate that? How can we shorten that intercept timing? All of this infrastructure has a multi-year time horizon for it to be designed and then deployed. And so if you're waiting, a year, 2 years, 3 years to trial a series of different technologies, compare them to one another in some sort of bake-off, and then select and design one in, that time frame can be so dramatically compressed for anything that's non-IP sensitive. And so this is a great example where the industry all shares an interest in seeing these solutions scale faster and where we can go faster together. So just incredibly excited to reach this milestone with Elemental. You asked about the unique sort of Elemental attributes that make them the right partner. And I think it's that history of being both a nonprofit participant in the space, but a venture investor as well. And so Elemental has experience doing something similar in the utility space. And then we had a positive bilateral experience on the Build Better Innovation Challenge about a year ago. And so that built some of the learning cycles to say, okay, Elemental is bringing that programmatic expertise for agile venture-based innovation and testing and de-risking. And then each of the end customers can come to the table and make much clearer to the innovators, all right, here's what it needs to look like in order to be able to get those first adoption milestones.
May I ask a question? Yeah. So when folks are coming to you all for this new program and we're talking about scaling and decarbonization, how do you all weigh the difference between pure cost and energy needs versus actually the decarbonization element for its own sake?
So I can answer for our company, but all of our peer companies are also participating, and they would have this, similar answers, or sorry, not similar answers. They would have their own answer. So at Microsoft, the way we incorporate sustainability decision-making into a total cost of ownership decision, for instance, is by using an internal carbon fee. And that carbon fee has been levied across the business group since 2012. And it reflects the sense that there is a social cost and that is borne by the business group that is deploying a solution. And it's different depending on the category of what type of good or service you're procuring. And so that's one way that we can integrate that. I think more generally, though, there's the sense that for the business to do well, it needs to grow sustainably. And that has, multiple different dimensions depending on the markets that we're operating in. We're a global business. We have operations in Europe. We have operations in Asia Pacific and in the US. And so there's regulatory regimes in each one of those that guide our priorities. And so I think we very much take the long view. We just had our 50-year anniversary as a company and recognize that long-term growth means sustainable business growth.
And I'll just add that, by nature of who we are, we focus on the environmental impact and the community impact of our investments. So we're sourcing the technologies, and the hyperscalers are providing, the baseline information that we need to know about what their needs are for the infrastructure, and they're providing advisory input. But that's going to be like a main focus of this program is the environmental outcomes, and we're going to layer in all of the things we talked about around scalability and speed to power and all of that. But that will be a core focus for us always. Yeah.
So I think I have a question for you then is, how does all this data come in to inform your analytics, and how much could you predict now before these investments go in about what the technology winners will be?
I love that question. The answer is every forecast is a guess, period. So don't let anybody tell you otherwise. Our core vantage point is you have to understand what knobs were turned and what assumptions were made. And if you can do that, then at least you can compare these guesses on an apples-to-apples basis. I would say at this point, from most technologies, we actually have a very good idea about what the embodied emissions of them are. Life cycle analysis has been something that's been around for a number of decades. It's quite well established. We have good data on these. I think supporting technologies and enabling technologies get much fuzzier. And so our position on this is you have to be able to point to the physical characteristic in the world that has changed as a result of the technology. If you can point to that physical shift, then you can model it confidently. If you're talking about software that enables a team to do something more efficiently because of X, okay, show me where in the world that atom moved or that electron did or didn't move. It has to come down to that. Once you can get there, it's actually not bad because then it comes back to what financiers have been doing for a long time, which is predicting what markets will do. And we're good and bad at that at the same time. But that's really what this is, the per unit impact. So for each widget, what's the reduction in emissions or water savings or waste reduction? And then how many widgets do you think you're going to scale over time? So it's really those two things.
So as somebody on the other side of this, who's put technology out in the world, I would say the third thing is the people, right? Some of the investment is about the team. And sometimes the technology is not going to work, but you bet on the team. I'm curious how Elemental thinks about this, or in this environment. Is it the technology? Is it the team? And how are you going to balance that?
It's always the team. The team is always, there's sort of like an interesting thing I learned in venture investing that folks kind of, as you're doing diligence, a soft thing you evaluate is the dynamics on the team and how the founders are interacting and are they getting along. But more important than that, you need to have multiple points of expertise, right? You need to have business people, you need to have the science people, and importantly, you need to have the project people and the people that know how to deploy in real environments. And that's something that early stage venture, you're building the thing and you're not, you don't necessarily need that expertise, but you need to have that expertise when you get to folks to where we're investing, because we're giving you money for projects and we want to see them succeed. And that's those are complex skill sets, right? Understanding how permitting works, understanding how to get through all the red tape that we talked about earlier is one piece of it. But we have 5 pillars of investing, and they're all, and the team is a huge portion of it.
I'm going to ask one more question, and then I'll turn it over to you guys, so you have time to ask lots of questions. I'm going to pick up on this idea of team and people, because I think we'd be remiss to not talk about the social questions that are happening and how communities are responding to these data centers and AI in general. And it'd be great just to hear from each of you your thoughts on what's happening in public discourse around this and how you would respond to some of the concerns from your chair.
So, like I said earlier, we're a nonprofit investor and we focus on investing at the intersection of environment and community impact as well. And so this is a part of our diligence process all the time. We ask founders, what are the unintended consequences of your technology? We try to evaluate if they're actually analyzing that correctly. And then as we scope projects, we always require a sort of community partnership element as well. And that looks different for different projects. But part of that is really educating communities about what are the benefits of this technology and not assuming that everyone's going to want this thing in their community. And so I think that it looks a lot for... we look a lot at the workforce component as a community piece, sort of a darling of the moment. I think you guys a lot of folks have probably heard of Fervo, which is an enhanced geothermal company that was in our portfolio. And we, as part of our investment with them, we paired our dollars with a project that was doing an apprenticeship program at a local community college. So it was not only teaching people about how enhanced geothermal works, but training them in the skills that would be needed for jobs there. So that's something that's how we go about it and try to, from a project lens, incorporate that into how we scale or how we deploy climate.
It's a big question. I think we should all be thinking a lot about it. I would say I'm still 50-50, frankly. I'm an eternal optimist, so let me put on my optimistic hat. I think a few things are still completely unknown, many things, but two that I'll call out. Number one, we have no idea what the actual infrastructure needs are going to be still. So a lot of this is proactive development that is in anticipation of a particular class of technology continuing on a trajectory that it has been on. And it would be silly to bet against the overall trend, but I think it would be equally silly to assume that the hardware requirements are going to be the same. And we have a lot that's going to be coming, even in things like quantum. I mean, we have a lot that's going to happen. So jury's still out. And on the physical needs, I think that we should all be very serious about making sure that they are built responsibly and sustainably for the long term so they don't become the malls of now, right? I mean, go into any mall and there's a lot of space that is unused. On the actual software side, I would say there's Guy Raz did his How I Built This with the CEO of NVIDIA recently. If you like that show, I would highly recommend it. It's a great episode. And I'll just take something that he said because it really resonated with me, and I think it kind of hits the point of the use of AI. He travels all around the world, and he kind of made mention that in the US right now, there's an incredibly negative sentiment around it, which is driven by a lot of elements, including some, I think, pretty belligerent statements on the leadership in this space that is not shared around the world. And I think that strategically, we should stop that and start thinking about what can we actually use this for productively. And I'm on the side of the fence of, I don't believe this is just going to take everyone's jobs. I just don't believe that humans are capable of sitting around in leisure time with a bunch of excess money and just sit around. We're not going to do that. And in my personal life, I'm experiencing something that's really remarkable because you can all of a sudden think about things much more conceptually in a way that you couldn't previously. Because if you learn what it's really good at and it can handle that detail work for you, now you're thinking conceptually at a level that you weren't capable of doing it. He gave the example of radiologists and how early neural nets are incredibly good at image recognition. And there's this big freak out moment of saying, well, if we can image all these medical images and AI can do it even better, why would we have a radiologist? And he said, well, right now, radiologists are actually in higher demand because you have higher throughput for lower cost and we can do more life-saving diagnostics faster. So I think that we should hopefully all take very seriously the downside risk of hyper-consolidation of power and knowledge dissemination. I get afraid of that, and I don't like the idea of 3 companies ruling the world, so I think that we should all take that seriously. But the implementation of this technology is incredible if we do it right, so I hope that we can push ourselves into that.
That's great, and I think of the question raised as really 2 sides of a ledger, and some of this will echo what my co-panelists have said. But on one side of the ledger, there is the resource footprint of building the infrastructure to support these tools. And importantly, that resource footprint is both global and local. And I don't want to lose sight of the global as we begin to pay more needed attention to the local resources. It has to be both and. On the other side of the ledger is the beneficial applications, not just for environmental outcomes, but also for public health outcomes and other economic growth and economic inclusion. And on both sides of the ledger, there's just an enormous cone of uncertainty. And it's quite speculative if you use what exists today to forecast out. You have this false sense of precision about what 10 years from now looks like. I am currently reading a book called 2081 that was written in the 1980s and meant to forecast what the future would look like in 2081. And I'm still in the first half of the book, so I can't tell you what they got right and got wrong. But what I can say is that already they were pointing to 5 major drivers of change, of technological change specifically. They pointed to computers, automation, space colonization, transportation, and energy and communications, which was lumped together. All of those, with the exception of space colonization, pending SpaceX IPO, whenever that happens, all of those have been tremendous sources of change over the last half century. And yet the specifics of what the forecast at that time were off. The Concorde had just come out, and there was this sense that while the average speed of travel was 600 miles per hour, that by this point in time, we'd be traveling 6,000 miles per hour through vacuum tubes as our primary form of getting from point A to point B. And so I say that mostly because the future is unknown, but that also means we get to write the future. And I think that for me, in my work and feeling excited about what is to come, it's about making it so. And so that's why I'm excited about the work we're doing with Elemental and the opportunity to make it so and to add some clarity out of that huge cone of uncertainty on both sides of the ledger.
That is awesome. We run a program here at Yale called Sci-By Sci-Fi that is about creating the future you want to live in with humanists and artists so that we have a path about where we want to get to. I think one thing we have failed at as an environmental community is telling people if we get this right, this is what it looks like. In not a utopian way, but this is what it could look like. And this is the benefit and why we're asking you to change or do this work. So super exciting. All right, I'm going to open it up to you guys so we can get some questions from the audience. Yeah. All right,
Great panel.
And the runner.
Great panel, thank you. Any thoughts on carbon credits and maybe their role in decarbonization?
Microsoft, as a company with a carbon target, has been an active buyer of carbon removal units, which are one form of carbon credits. And that is a small fraction of the overall carbon credit market, which is generally avoided emissions offsets. To overuse the ledger analogy, there's a number of interventions that one can make in infrastructure and other corporate operations that reduce emissions. And there will almost certainly always be some residual for which it makes more sense to, in our perspective, remove as opposed to reduce. Now, the size of that residual, the appropriate cost, those are worthy debates that could take they could be their own summit. And I think that it's a useful tool. It's a waste management tool, effectively, for global resource management.
Yeah, I'll take that one in a few different ways. I think critical and yet elusive. Voluntary carbon markets are just not working well, unfortunately. You look at a few of the regulated markets and it's actually quite exceptional. And I think that if you kind of boil it down, it's that in basic capitalism, externalities are not priced in very well if they're not going to directly impact the bottom line in the next few quarters. And so with this invisible gas that's getting emitted into the atmosphere that isn't going to have an impact for a number of decades, I think that we've had a really difficult time figuring out how to have just basic capital forces deal with that. So in regulated markets, I think it's exceptional and you see really good progress because you just have this ratcheting effect of price that will cause you to either buy and then all of a sudden your financial ledger doesn't look very good, or you're going to look for a solution to it. So I hope that we get more progress on the regulation side for that.
I have some really smart colleagues working on the nature-based solution side that are deep in the carbon markets. And I think for me, when we do diligence on companies, we want to see that the business model works in the sort of infrastructure side. Without that, because we know it's not a universal market. And so, yeah, it's, I would say emerging, but still not the main way that we choose to make investments.
Yeah, don't you feel that the carbon markets are a bit like playing with cryptocurrency in terms of the scams that are going on? One comes out every week about some scam that people were doing with it. I'm a fan of obviously getting rid of it and decarbonization, but carbon credits just invite abuse. You guys aren't finding that?
Sure. I agree with the premise. I don't know enough about crypto to speak to crypto. But knowing what I know about the carbon markets overall and specifically voluntary carbon markets, I think a quality floor, an enforced, ideally regulated quality floor is what's needed to make that happen.
Yeah, agreed.
Sorry, you guys.
And auditability. I mean, that's it. Is that there's no ability to have an apples to apples comparison right now because there's no enforceability.
Yeah,
and until you get that,
liability by who?
well, that's the thing. I mean, until you have some forcing function, then it's just the Wild West.
Good
And-
one.
Right.
Thanks, guys. It's great, very interesting. Love the work of Elemental. Obviously, what you do is amazing. When you look at the scale and the speed of deployment of data centers all over the world, it still feels a bit too little, too late. How do we either, on one hand, slow down the pace of infrastructure deployment, because we're making huge capex investment right now, or on one hand, or how do we 10x what you guys do? Because it feels like we are really deploying things at a pace which is like we don't even comprehend the consequences of that. So how can we do either or both maybe?
So this initiative that we're running is 2 years, and we are focused on getting investments out the door in the first 6 months to get this data fast. So to your point, we understand the urgency, and that is where we're really focused. I think that like our hope is that this is a first program. But if we can show success and that we can be showing these investments and these projects are working, then we can scale this up in a more meaningful way. So that's how we're looking at it from our lens of how we are trying, because like I said, if we can get these technologies in our portfolio that that they work, but they haven't been deployed in the scale, we think that will be the sort of takeoff effect. So that's the angle that I'm coming at it, of how I'm trying to solve this problem for now.
Great.
What do y'all make of the behind the meter sort of trend? I mean, it seems like on the one hand, it may be beneficial in the sort of rate base aspect, but at the same time, then you look at Memphis, or you look in Louisiana, where Meta's going to build more natural gas in the entire US over the next year or two. How do you balance kind of the scale and speed benefits with the real sort of governance gap that emerges when we're overlooking or bypassing all of the energy governance we have in place?
I think that what we need is a grid system that can move faster and be more flexible, so that you have a viable alternative on the time scale and technological performance that's needed. I think that these two are not off-grid versus on-grid. On-grid is preferable. It should be on-grid. And we need to make the system flexible enough, and we need to make the system fast enough to make that a reality.
But can anybody but the government make that happen? I mean, you're talking
I don't
billions.
quite know how to answer that, because I mean, that's an energy market design question in some sense and a grid operation question. So I think that it's like the entirety of the grid system needs to evolve.
Yeah, please.
It's also a NIMBY question, and
Yes.
eminent domain. I mean, you're in the state where Little Pink House, the book Little Pink House was written about. So like, you're gonna have to take a lot of land from people who may not want to be taken. But my question is actually a little bit different than that. Why wasn't nuclear energy more part of this discussion about decarbonization? Because that seems to be the best baseload power option for decarbonized power out there right now. And given distributed nuclear and small scale nuclear reactors being part of the startup community, shouldn't that be part of this discussion more intently?
Yeah, it's a great question. For us, we're really focused on results in the next 2 years. And that is why, because Elemental in particular is so focused on the deployment challenges, we look at that sort of what is deployable in the next 2-year horizon. SMRs definitely are really interesting, but from what we've seen, we're still not in that sort of time frame yet. I think there are a lot of folks are focusing on that, especially in the data center context. And we're also talking about scale, right? There's huge nuclear projects that are coming online that are kind of outside the scope of this program that we're working on. Huge geothermal installations, all of those clean firm power is really important. But we're looking at what can we be doing near term, and also while these things are being built long term, which are much heavier infrastructure plays.
Can you paint me a different picture of what the infrastructure development would look like? Taking Julie's thought on the sort of sci-fi, not the sort of Fermi, we're trying to build a 17 gigawatt data center in Texas and lighting $750 million on fire. But what does a distributed, engaged, kind of community-centered build-out of AI infrastructure actually look like? What would that be, and how would that actually come together?
I mean, I can share that this is a little bit of the way back, way forward machine. It'll be the Back to the Future. So we've looked at a range of different designs, and I think this is where divergent thinking, for everyone looking to develop solutions in this space, this is where divergent thinking comes in, right? We've looked at what does a regenerative or regenerous data center look like, one that is resource positive. We're continuing to work on this. One that is resource positive for the local resources within which it's drawing. We and Google have, sought LEED certification. That's a much more convergent, existing system. And then we've looked at underwater data centers. There are some startups out there, including one that Elemental is involved with, doing tidal power, floating out in the middle of the ocean. There's space. I do think the latency problems, might be worthy of some attention. But I do think, and maybe this is the happy hour conversation prompt for everyone, which is what comes after these large centralized form factors. I think that is one of these things that is unwritten. You could have a distributed compute scenario and form factor that would look different from how we're building these things today, and it might have land use benefits, and it might have water benefits, and it might have energy benefits. And there's a whole bunch of pre-existing conditions that need to happen to make that a reality. But it's not out of the question at all. And I think that's the type of thinking that this industry is ready for.
Definitely agree. And in terms of the story not being written, I think we still have to figure out what really we're going to be using these for. If within a generation or two, local inference is going to be just as good as our current frontier models. And what does that mean? Well, I can have, again, the MacBook Studio that we've all heard of running OpenClaw or whatever, which is not where it's going to go. But once you get to the point of local inference, if it's doing what we need it to do on an individual basis, that looks very different than having to shuttle everything out to a data center to come back. So we don't really know what the capacity is for yet. I mean, most of that load is actually not on code generation outside of the very large, GitHub, in Microsoft ecosystem. You're talking about massive inflows of AI generated code, but that is actually relatively power light. Then you look at something like Sora, which is shut down, I'm pretty sure now. But when you're talking about image and video generation, well, yeah, that's massively complex, and you can't reasonably today run that anywhere local. So I think we still have to figure out what is it going to be used for, and is modular really real for the types of applications that this generation of AI is good at, and what comes next. So story is very, very uncertain on that one, but hopefully we get more modular, just like we need on energy. So it's not so monolithic.
I guess the one thing I'll add, and we really focused on the energy piece here, but the materials store is also really important for data centers and the new builds that we're doing. And something that really excites me about this opportunity is, low carbon cement, for example. It exists. There's lots of companies doing it, but they just haven't been able to get scaled up in a way to make it pervasive across the industry. And so if we can use this opportunity to have data centers using low carbon cement and the implementation, that really changes the dynamic of local suppliers will now have the market impetus to move to low carbon cement. And so we can make those sort of shifts more broadly. So that's what we're really hoping in the materials side as well. In addition, and you asked about behind the meter. It's such a lost opportunity, right? If that's the way it goes. And from the research we've done, I don't think that's the way it's going. They're all looking to be grid connected. And if we can create these systems to be net positive for communities that we're doing energy surpluses, that would be my ideal if we can come out of that in the next couple of years.
Thank you. Great panel. Sam, you mentioned that you're interested in environment and social impact, and I think it was you also who mentioned health. This will be no surprise to Juliet that I'm asking this question. This may be a bit beyond the scope of your work, but I'm curious for you at Elemental or the others, how you, I don't know if it's balance or maybe it's create synergy between planetary health and human health. How much are you thinking about health as a benefit, not just a co-benefit, but really a benefit?
Yeah, that is absolutely part of how we look at projects, and it's really easy to think about it in terms of like when we're talking about local emissions and driving down those in communities, right? Like all the projects that we invest in are clean energy projects. And so if we can quantify that, and we really can, we've done investments in the past in, for example, the drayage industry, which is heavy duty trucking. And this is a really heavy polluting industry that really disproportionately affects low income communities that live near ports. So that was something that we really wanted to focus on because it not only had the environmental impact, but the health impact as well. And you can really see it in the data. The cancer rates are higher there. There's, just a lot of negative outcomes. So that is totally part of our thesis. The two are very intertwined, and we really look for opportunities where we can move the needle on projects there.
Yes.
Sorry.
Oh, sorry.
Just quickly on that one, I'm just going to go back to externalities again. Unless you can get a dollar sign attached to the company doing the thing that causes the thing, then very little ends up happening.
Yeah, so this is probably a follow-up question on Stu's question. And when we talk about the future state of compute and data centers and grid and hyperscalers, and we as consumers consuming products like OpenAI and Anthropic, do you foresee a future wherein flexibility can potentially contribute to the uptime, which is like 5 nines of what is required today? And we've been seeing some cues from, for example, Google, wherein they potentially claim that flexibility, particularly I think temporal and spatial, both can contribute to the congestion that we are having in a positive manner. But from the rest of the hyperscalers, what is going on in those board conversations when you guys sit and talk about how to solve this? Is flexibility part of that conversation?
I'm happy to take that one. I think that the flexibility that you can see depends on the type of workload. And so for 1P workloads, that is workloads that are being consumed by the owner operator, then it's a very, it's a viable solution. And I think that for third-party workloads, it depends on the customer expectation. What have you contracted or promised the customer in terms of their uptime? The great thing, though, is that these are not the only loads in the system and not the only way to have this infrastructure invest in flexibility. You can also have tariffs that pay for flexibility elsewhere in the system. And so I do believe that system flexibility is an important element of looking left to right and saying, what are the non-wires alternatives? But that won't necessarily be workload shifting, or at least not for the sort of enterprise 5.9s. I think you could have a migration, and we're seeing it in the lessor space, change in what those SLAs are and the type of workloads they take on. Verus is an example of one of these companies. The other thing I would point out is, in terms of this concept of the data center of the future, you also have, in terms of near term and medium term solutions, you also have the ability to use superconducting cables to dramatically increase the density, so that the same workload could take a tenth of, or half or a tenth of the density, of the space, and therefore the embodied carbon, by 10xing the density. And so that's like one more accessible element of this as well. Those would be another one I would give.
Maybe one more question, and then we'll wrap up. Yeah, please.
Quick one. I've only learned recently that these data centers produce a tremendous amount of noise, making them not the best neighbors. Could you speak to if that's something you're evaluating, or if these new methods that you're piloting may mitigate some of that?
I think that will definitely be part of the conversation. We're looking at in technologies deployed in the data center environment. So it's good. It's not the holistic data center, but I think if there is an opportunity to drive down those kind of negative externalities, like, we will definitely look at it. We just launched today, and so I think that as we see these come in, I think, my assumption is that the cleaner technologies will be less noisy, but we'll need to validate through once they submit their applications.
Cooling has a lot of innovation to go. And this is actually one nice co-benefit of data centers, I'd say, is that cooling is a real beggar. There's a lot of people who have a lot of money on the line to figure that out.
Oh, we're going to wrap up. So I'm sure our panelists will hang out and take some questions. I'm going to ask them, and I'm selling this to you so they have a minute to think. This has been a very techno-optimistic, I would say, panel, and it'd be a great one to hear about what you use AI for. Like, what's your favorite use? And then what is your biggest worry as this goes forward and scales?
This is personal or professional?
Anything you want.
Oh man, it's ironic because I feel like I'm just at the beginning stages of using AI, and I think for me, we've been taking in an incredible amount of data and information around data centers, and I'm really excited, like, selfishly, to see how we can bring this into a more robust diligence process of, like, all the sort of technical studies that are out there and all the science that, we kind of usually leverage one-to-one human communication, how we can kind of scale that ability.